Hello friends, welcome to NPTEL online certification course on soil and water conservation engineering. I am Rajendra Singh, professor in agriculture and food engineering department of IIT Kharagpur. We are in week 4 lecture 17 and the topic today is bench terraces. Just to give you an idea about the course content of the week, in the previous lecture, that is the starting lecture of this week, we started with the introduction of terrace. In today's lecture, that is lecture 17, we will go through bench terraces. In lecture 18, we will utilize the concepts learned in this lecture to solve problems dealing with the design of bench terraces. In lecture 19, we will go through broad based terraces, and in lecture 20, we will solve problems dealing with the design of broad based terraces. So, let us start with bench terrace. Just a recap, bench terracing consists of construction of a series of platforms along contours cut into hill slopes in a step like formation. So, basically series of platforms, that is what bench terraces are, and they are constructed along contours and primarily meant for hill slopes, that is wherever the land slope is steep and there is a step like formation that is created after cutting the soil. So, as you can see here in this picture, this is the original landscape, and as you can see that the cutting and filling operation has been done so as to get these step like structures here. There are series of steps which we can see here, and these are referred to as benches or bench terraces. And platforms are separated at a regular interval by vertical drops or by steep sides and protected by vegetation and sometimes by stones retaining. So, this means that these platforms or these steps, they are separated at regular intervals by these either these vertical or slanted, and these are referred to as risers. These are vertical drops, these are referred to as risers, and they can be vertical or they could be having some slope, and if there is a slope, then typically they are protected by vegetation or some kind of stone chipping, so as to avoid any kind of erosion that might occur if water falls from the upper platform to the lower platform and so on. So, this is what bench terracing is all about. They are typically adopted in a area where the land slope is 20 to 30%. That means, they convert a steep slope of 20 to 30% to a series of level or nearly level benches. So, that is what it is done basically, and they, as you can see that adaptability is 20 to 30%, and as you can guess that because cutting and filling operation takes place at that elevation, that is steeper slope. So, obviously, it is a costly affair, and that is why bench terracing is a costly conservation measure. And here, as you can see, earlier also we saw this is the original land slope, which is 20 to 30%, and here these level or nearly level benches are constructed. These could be either level or they could be either sloping outward, that is if slope is in this direction, then we call it sloping outward, and if slope is in this direction, then we call it sloping inward. So, when we sloping inward is this one and sloping outward is this one. So, slope is inside or slope is towards outside, that defines. So, and there are three types of level. This is the horizontal one is level, sloping inward and sloping outward, and riser, as we have already seen, it may be vertical or inclined, and if inclined, then typical slope is half is to 1 or 1 is to 1. So, either half is to 1 or 1 to 1 commonly adopted slopes of riser. These are the commonly adopted slope of the risers. Now, coming to classification of bench terraces, uh, based on the slope, bench terraces are classified in three different categories. First one is absorption or level or tabletop terraces, that means three possible names are there, either level or tabletop or absorption. The second one is outward sloping, and third was the inward sloping. So, there are three types of terraces which we have seen earlier, that level, outward sloping or inward sloping, and if it is level, then it is also termed as absorption or tabletop terraces. Let us see these terraces one after the other. Now, starting with absorption or level or tabletop terraces, as the name itself suggests, the step like structure or bench is level, in this case completely horizontal, and they are constructed exactly on contours and provided with sufficient freeboard, so that they can trap all the rain that falls. So, basically the main function is moisture conservation or water conservation, and that is why the term absorption is also used, and that is why in fact, in all kinds of terraces, this shoulder bund, this is which is here, that at the end of this we create a bund kind of structure, which is referred to as here small one. So, just to I am magnifying the same thing, so that it is clearly visible, and this is referred to as shoulder bund. So, in this case of a level or tabletop terraces, the sufficient freeboard should be provided, so that all the rain that falls can be trapped. So, we do not allow any moisture or any water to move away, and we wish that all the water that all the rain that falls over this particular area, over the tabletop, this is all conserved, and these are suitable for areas having evenly distributed medium rainfall and having deep and highly permeable soil. So, rainfall has to be medium, and the soil characteristic is very important. The soil should be deep enough and it should be highly permeable, or the infiltration capacity of the soil should be high enough, because if the infiltration capacity itself is not high and these terraces are designed in such a way that no water will be allowed to flow out. So, obviously, that will create waterlogging situation, and that might create a problem for the crops, or at the same time it may also hamper the machinery operation. So, that is why it is very important that whenever they are adopted, the area has to be of medium rainfall size, and the infiltration capacity of soil should be significantly higher, so that they can retain most of the almost all the rain that falls over these benches, this area. Then next one is outward sloping terrace. As we already saw, that you can see that had it been a level, then it would have gone like this, but we see that there is some slope given in outward direction, and that is why it is outward sloping terrace. And bench terraces sloping outward are effective in low rainfall areas with a permeable soil of medium depth. So, they are preferred or adopted in low rainfall areas, and where the soil is of medium depth, but which has permeable, I mean infiltration capacity is high. At lower ends of this terrace, graded channels are provided for safe disposal of runoff. So, by the side of this shoulder bund here, a channel kind of channel is provided, and the grade is provided perpendicular to the screen here. So, that whatever excess rainfall that occurs, that is taken out safely from the area. And of course, shoulder bund is essential, because if shoulder bund is not there, because of the slope this direction, the flow velocity will be much higher, and if we allowed to, which water is allowed to fall, then it will cause severe erosion in the lower branches or in the riser itself. So, that is why shoulder bund is very essential in this case. And these outward sloping terraces, they are useful for slopes up to 15%. That means, their adaptability is limited to slopes of 15%, and they are suitable for orchards. So, wherever orchard plantation has to take place, or wherever the slope of the land is limited to 15%, then we go for outward sloping terraces, and provided it is a low rainfall area and soil medium depth soil of permeable higher infiltration capacity is available. The third category is the inward sloping terrace. So, as you can see here, the slope is in this direction, otherwise had it been level, the level terrace would have been like this, but as you can see that there is a slope, considerable slope in the inward direction. So, bench terraces of sloping inward type are more effective in heavy rainfall areas. So, they are selected in heavy rainfall areas. So, we have three different categories: level benches, which are for medium rainfall, then outward sloping, which is for low rainfall, and inward sloping, which is for high rainfall. So, I mean, categorization could be based on rainfall itself, and a suitable drain at a inward end of each of these terraces is provided to drain the runoff. So, obviously, whatever rainfall occurs, that gets drained towards the inner end of the terrace, and thus a channel is provided with sufficient grade perpendicular to the board. So, that whatever excess runoff is generated, that is safely taken to a outlet, and these prevent ponding of water and are useful for crops that are susceptible to waterlogging. So, obviously, because they are designed in such a way that whatever excess rainfall occurs, that is quickly that flows towards the channel here, and that is taken away from the area. So, obviously, there is no question of ponding of water in this case, and that is why they are suitable for all crops that are susceptible to waterlogging. So, anywhere if you want to grow any crop which is susceptible to waterlogging and where the rainfall is significantly high, then we have to choose this kind of terrace, that is inward sloping terrace. So, now we go to design of bench terraces. So, design of bench terraces consists of determining the following, that is type of bench terrace, terrace spacing or depth of the cut, terrace width and terrace cross section. So, when we say we want to design a bench terrace, then these are the four decisions we have to make. What is the type of bench we are selecting, what is the terrace spacing or depth of cut, what is the terrace width and what is the terrace cross section. And for doing so, we require certain data for sure, and these data are average annual rainfall, soil type and depth, average slope of the area and crop and soil management practices. So, these are the essential data which we must have if you want to design a bench terrace for a given area. Now, selection of the type of bench terrace, which is the first design decision we have to make, that depends on rainfall and soil conditions. So, already we have seen there are three types of terraces and the adaptability also have seen. So, for example, if moderate rainfall occurs in an area having highly permeable soils, then level or tabletop bench terraces are recommended. So, we have already seen that three types of terraces for three different kind of rainfall conditions, and of course, the soil characteristics have to match. On the other hand, if an area has high rainfall and crops are susceptible to waterlogging, then inward sloping terraces are preferred. So, depending upon the rainfall and the soil characteristics, also the crop and soil management that we are going to adopt in a given area, we will choose what kind of bench terrace we are going to design or choose for a particular area. Then this is a little bit detailed definition sketch of bench terrace. Already we have seen this, but important point here is that a riser slope which we talked about, that it may be vertical, it may be having slope of half is to 1 or 1 is to 1, that is referred to as batter slope. So, whenever we say batter slope, it simply means the slope of the riser we are talking about. Then obviously, we have already seen that cut and fill is there. This is cut, this is fill, cutting and filling is there, by through cutting and filling only these benches are made. So, this is basically the depth of cut, that is the base of the terrace, and from the point where the original slope is getting changed, this is the original slope. So, this is referred to as depth of cut, and then the horizontal interval from starting to lower point, that is referred to as width of terrace. So, this is depth of cut, this is width of terrace, and of course, the shoulder bund design is very similar to bund, and this is the batter slope. So, these are the some of the design parameters which we have to discuss. And one important thing is that the volume of soil to be cut and fill is kept equal to minimize the cost. So, obviously, whatever we cut, if you fill, then obviously cost will be minimum. So, cutting and filling is balanced, that is what we try all the time. Then coming to terrace spacing. Terrace spacing is the vertical distance between two successive bench terraces. So, very similar to the bund we have already seen, vertical interval, horizontal interval, similar concept is used. So, if you simply take two corresponding points, then we will get the vertical distance is vertical interval, and that is why it is similar to vertical interval we define in case of bunds. And obviously, as you can see here, this is the depth of cut and this is the depth of this is the fill, and because we have already said that we try to balance keep a balance between cut and fill. So, that is why typically it is equal to twice the depth of cut. So, because depth of cut and depth of fill is more or less similar. So, that is why it is twice the depth of cut, and of course, it depends on value depends on soil depth and land slope, and prevalent local practices and practical experience guide the decision. So, what should be actually the vertical interval, that will not only depend on soil depth and land slope, but also what are the local practices and what is the experience in a given area. Based on that, we decide the vertical interval. Then comes width of the terrace. Now, width of the terrace should be age per requirement, that is the purpose for which the terrace is being constructed. And obviously, because we want these terraces to be cultivated, and so there could be there should be the width should be sufficient for to support cultivation, that is the fundamental. Now, width depends on the soil characteristics, as wide benches require deep soils and higher construction, they involve higher construction soils. So, higher the higher the width, obviously the depth of cut will be more and cut and filling will be more. So, construction cost will be higher, and of course, if depth of cut has to be more, then soil has to be deep enough. So, that cutting could support the cutting. So, typically recommended widths are 2.5 meter to 5 meter for manual cultivation and 3.5 meter to 8 meter for mechanized cultivation. So, if it is purely manual cultivation, then it could be 2.5 to 5 meters, but if it is a mechanized, then it has to be wider, that is 3.5 meters to 8 meters. So, these are the typical recommended widths. Now, once the width of the bench terrace is decided, the depth of cut and the vertical interval can be calculated. Their relationship can be used for doing this, and we will see how to do that. For example, when the terrace cuts are vertical, that means riser is vertical. So, we discuss a case where riser is vertical. So, obviously, in this case, if you consider the figure here, that is A, B, C represents the cut. So, this A, B is d by 2 and this width of the terrace B d is W, and at this point, that is B C, this is W by 2, and this is depth of cut is d by 2, that we have already seen. At the same time, we also know that the land slope is S%. So, that means, if we consider a triangle M and A, So, Mn is S, this is S and this is 100. So, that is S meter fall over 100 meter, that is the concept we use. So, in that case, if we consider triangle AMN, NM is S and AM is 100 because the land slope is S%. Now, we consider triangle AMN and triangle ABC as equivalent triangles. So, that simply means what? That is d by 2 by w by 2 for triangle ABC, that is d by 2 by w by 2 is equivalent to S by 100 for triangle AMN or NMA, whatever you call. So, S by 100. So, from here we get D equals to WS by 100. So, this is the relationship between D, which is nothing but twice the depth of cut or the vertical interval. So, D is vertical interval and W is the width of the terrace, S is the land slope. So, S is the land slope in percent, D by 2 is the depth of cut and W is the width of terrace. So, very simply we can find a relationship between D and WS, that is D and W, that is D equals to WS by 100 when the terrace cuts are vertical or riser is vertical. Very simply we can find out. So, the vertical riser or the vertical cut is used only if the soil is very stable or when the depth of cut is small, that is only up to 1 meter. So, if one depth of cut is limited to 1 meter and soil is stable, then only we go for vertical risers. Usually, for the stability of fill or embankment, a better slope of half is to 1 or 1 is to 1 is provided. Typically, we use a better slope. It must however be kept in mind that flatter the better slope, larger will be the area lost due to bench terracing, which is quite obvious, because if we draw a bench here. So, if this is, let us say that this is the land slope. So, if this is typically for vertical we are saying, but if we make this slope larger, that means this terrace will be here. So, this will be much larger. So, we are losing much larger area under the terrace as far as cultivation is considered. The relation between the width of terrace and the depth of cut for better slope of half is to 1 or 1 is to 1 can also be easily found out. For example, when the better slope is 1 is to 1, so that simply means that this is d by 2 and this is also d by 2. This is because this is our 1 is to 1 riser. So, that simply means what? That this distance, because the width will begin from this point. So, this distance BC becomes W by 2 plus D by 2. So, this is the relationship we get and D by 2. So, here using the equivalent triangles ABC and AMN, in this case we will get D by 2 by W by 2 plus D by 2 equals to S by 100, or D comes out to be WS by 100 minus S, that is when riser slope is 1 is to 1. Similarly, when the better slope is half is to 1. So, in this case this will become d by 4. So, it was d by 2 and now it is d by 4. Earlier it was not existing in vertical case, and then from this we get this relationship d equals to 2s 200 minus s. And we can also write a general relationship for this case, that is d equals to Ws 100 minus SSR, where SR is the riser slope. So, if SR is 0, that is for vertical, we get this relationship. If SR is 1, that is 1 is to 1, we get this relationship. So, basically this is the generalized form in which we can also write the equation. Now, coming to terrace cross section. So, design of terrace cross section consists of dimension of the shoulder bund, inward slope of the terrace and dimensions of drainage channel, if it is sloping inward type, or outward slope in case of sloping outward type. So, these are the decisions we have to make as far as terrace cross section is concerned. Now, coming to shoulder bund dimensions, it depends on the type of bench terrace. In case of terraces sloping inward, the size of shoulder bund is kept nominal, because it has almost no function. But in case of terrace sloping outward or level top, shoulder bund cross section is larger, because in both cases it has to hold water, rainwater on table terrace top basically, especially in case of level top. So, typical dimension shoulder bund used in bench terraces sloping outward is given, that is top width is 30, bottom width is 120 and height is 145 centimeters. This is a typical, we can design of course, depending upon the size of the terrace and so on so forth. Coming to inward and outward sloping terraces, the inward and outward slopes of bench terraces depend on soil type and average rainfall. Inward slope varies from 2 to 10% and outward slope is from 2 to 8.5%. So, these are the general ranges. For inward sloping terraces, a drainage channel is to be provided the inner edge, that we have already seen, to dispose of the excess runoff, and channel dimensions are calculated knowing the excess runoff magnitude and using the Manning's equation to ensure non-erosive flow velocity. So, runoff magnitude has to be of course found out, and then Manning's equation has to be used, so that flow velocity remains non-erosion, so that there is no erosion taking place in the channel. Now, coming to area lost under bench terrace, the cultivated area lost due to bench terracing can be calculated as follows. When the batter slope is 1:1, so let us say that D is the vertical interval of the benches to be laid out on a land with a slope of s% along AB. So, AB is the land where vertical interval is D, and we have to lay out bench terraces, and batter slope of riser is 1:1. So, L is the horizontal interval between the benches, that is projected length of AB on horizontal plane. So, this is what L is, and this is what D is all about. So, if we consider this basically this, then this is L, this is D, and so and this is AB of course. So, from this we can write AB equals to square root of L square plus D square, and then taking L as common and expanding the series, we will get this, but we only consider the first two terms because beyond that it becomes insignificant. So, then it becomes AB equals to L plus D square by 2L. This is equation number 5. But we know all along that L equals to 100 by S, because 100 D by S, because land slope is s%. So, then we can put L equals to 100 D by S in equation 5, that is AB equals to 100 D by plus D S square by 2 L. So, that is why 100 D comes below and S goes up, or we get S 100 D by S plus D S by 200, because D and D gets cancelled here. And then we know that the W is the width available for cultivation after terracing. So, the total width is W plus D, which is equal to L or 100 D by S, or D W from here is 100 D by S minus D, D we are taking on this side, and then we are just simply writing this. So, width which is not available for cultivation is AB, which was the original width, and W which is available for width available for cultivation. So, simply we are putting values of AB and W here, 100 D by S plus D S by 200 minus 100 D by S plus D S by 2, and on simplification we will get D S by 200 plus D S by S. So, this is equation number 8. So, width loss expressed is percentage, that is this is, and this is original width, that is equation 8 divided by equation 6, and then manipulation or simplification we get this, and then if we divide both numerator and denominator by 100 S in this case, then this is what the resultant value will be. So, the percent width lost in percentage of original width is this, and this is also taken as the width lost may be taken as the percentage area lost, because it is a unit length we are considering. So, this is how, if 1:1 riser slope is there, this is the total area that is lost, the cultivable area that is lost because of the terraces. Now, earthwork per hectare can also be considered. Earthwork involved in construction of different types of bench terraces is needed to compute the cost of earthwork, and computation of earthwork involves finding the volume of soil that is cut, which can be obtained by finding the area of cut section, which is a triangle, and multiplying it by length of terrace. And terrace length is obviously 10,000 by W, or that is width of the terrace. If it is 1:1 riser, then it is 10,000 by W plus T. So, this is how we can find out the terrace length, and then if volume we have to find out the area of the triangle. And for the vertical riser, it is very simple. We have to find this area, and it comes out to be, area is half d by 2 by W by 2 or d W by 8, and volume of earthwork will be d W by 8 times length, which is 10,000 by W. So, if we W gets cancelled. So, we get 1250 d cubic meter per hectare, that is the earthwork per hectare. In case of riser is 1:1 slope, the volume of earthwork can be calculated by putting the value of d estimated for equation 2. So, here we can put the value of d, which is W s by 100 minus s basically, to get the volume of earthwork for 1:1 riser or for any other riser for that case, that matter. So, volume of earthwork also can be found out for inward sloping terrace, which is given by this relationship, and for outward sloping terrace given by this relationship, where S is the inward or outward slope of the bench terrace. This can also be derived like we have derived for the vertical riser case. So, this is derivation is very simple. So, W 1250 times the width we have to put, that is the important point here. So, this is what it is. So, we have discussed bench terraces, how to find the relationship between depth of cut or this vertical distance and width, how to find out the total area lost under terrace, or how to find out the total earthwork that is involved in per unit hectare area of terracing. So, these derivations, if you practice, it could be much easier, and then in the next class we will see how to apply that in order to design bench terraces. Thank you very much.